Hey guys, my name is Sandeep Patel. I'm a founder of Slotify.ca. In this video, we're gonna learn how many different ways we can search inside an array, right? Okay, so there are two different ways we can search within an array, right? So there is a linear search. The linear meaning that it goes in one direction like this, right? So when we start from array element 0, we loop until end of the array, and then we'll try to find our target element. Let's say we want to search number 6, right, in this array. So how do we do that? So we start from 0 until we get to this index, and then we can check what's in this index. If we, then we compare the element at this index with our target element, and then we can return from here, right? So this is how the linear search works. The binary search. So binary search does not work with unsorted array properly, right? And there's a reason why. Because in the binary search, what you have is you take the left element, you start left pointer. So you define left equals 0, you define right equals the end of the array, right? And then what you do is using this left and right, you try to find the mid element, right? So in this case, left plus right divided by 2, that gives you this index, right? So let's say if this array is not organized, what happens is, let's say that we're searching for number 8, and this number 8 is somewhere here, right? And then what happens in the binary search is that uh, at the mid index, we're trying to see if our target is less than mid or greater than mid, right? If the array is unsorted, then this logic will not work, right? Because you might have the mid element 5 and this target element 8. If you do less than 5 less than 8, it's not gonna work, right? And that's the reason why whenever you're doing a binary search, you need to sort the array first, right? So sorting is the first step when you are doing the binary search. All right, let's look at this practically so that you understand. Okay, so here we have two functions, linear search and binary search, right? So in the linear search, we're passing an array 1 2 3 4 5, and we want to search where the 4 is, right? At which position we can find element 4, right? We want to return the index. If we don't find index, then we can return -1, right? So let's say we cover base case first. Let's say we return -1 when we don't find index, right? So that is the base case. Alright, so in linear search, as I said, we simply run a for loop, start from 0, and that is until end of the array, dot length, and I plus plus, and then we check what is at array index I, right? If that matches with our target element, then we return I, right? We simply return that index, right? So if we run this code here, right, I have to put this in console log so that we see what is returning, right? Okay, so this should return index 0 1 2 3. So this should return 3 because the fourth element 4 is at index 3, right? And that is correct. And what's the time complexity of this code? So this is pretty simple. We're running from 0 until n, and this n is the input array, which is dynamically. So we don't know what is the size of array. This can grow dynamically. So for the sake of our consideration, we can say it runs until n, where n is equal to array length, right? So it makes from 0 to n iteration, right? So how many times this if code will run, right? So this if code is running O of 1 time, right? Like, because it's a static, it doesn't depend on input right now. But because this if is within this for loop, now it affects, right? This if is affected by this for loop. If this for loop runs n times, then this if will run n times as well, right? Even though, let's say this function, right now you're passing array length equal 5, right? So when you run this function, this for loop runs 5 times, and it will also execute if statement 5 times. And because n equals 5 right now, this will return O of n, 1 into n, right? It is affected by this outer loop, and so that's the time complexity of this code. And we don't care about this because this return is like O of 1, right? And in big O, we only concern about the big term, which is O(n). We don't care about this lower term. And space wise, we're not using any extra variables here, right? So we can say O of 1 is the space complexity here. How about the binary search, right? So binary search is very tricky, right? And as I said before, binary search won't work if you don't sort your elements, right? Let's take a look at with and without sorting, and we will see what happens, right? Okay, so let's try without sorting first. So in binary search, we take the left pointer, right? So which is start of the array, and then we take a right pointer, we put which is array.length, right? And while left pointer meets right pointer, we find out the mid. So mid index is what? Math dot floor left plus right by 2, right? We can put this in a bracket, and then all we do is, let's say whatever we find here, that's what we're comparing here, is that our array mid index, if it's triple equals target, then we return mid index, right? Okay, so in this case, let's say that this is the first element, this is the last element, and the index mid index is 2, right? So in this case, it's going to check if 2 is equals 3, right? Which is not. So in this case, it's gonna go on the left side. So what we check here now is that our target, if this index is not a mid index, if our target is on the left side, right, in that case what we do is we increase left equals mid plus 1, mid index plus 1, right? Otherwise we shrink the right side, minus 1, right? Okay, so basically what we're trying to do here is that if this condition is not met, right, so we're trying to check here that 2 3 triple equals 3, right? If this is not the case, then let's say if 2 is less than 3, right, which is not, right, which is true, that 2 is less than 3, so it's gonna look on the left side, right? And then so now we're shrinking this array, right? So now the left becomes mid plus 1, right? What does that mean is that our index is starting from here, right? So now we're looking at this. So our array now start at like this, right? So now this becomes your left side, and and the remaining element on the right side, right? So we're looking for this side, right? If we can't find, then we will check if 2 is greater than 3, right? If that is the case, we shrink the right side. In that case, we want to look on the left side, right? So in this case, if we don't find anything, then we return -1, right? So because this array is not sorted, I assume that it's going to return -1, even though we have element at 0 index, right? You can see that, and that's the reason why we need to sort the array, right? So when we sort the array, what happens? Array.sort a b a minus b, right? So we're sorting array in ascending order, right? So now if you check console.log, so now our array is sorted properly in 1 2 3 4 5 order, and now we will be able to find 3 at index 0, right? Oh, sorry, the index 3 is at 0 1 2, index 2, because we sorted the array. So we found our 3 at position 2. Alright, and so this is how binary search works. So because we are using array sort function, right, this is a inbuilt function which has time complexity of n into log n, right? If we consider the overall complexity of this loop is O of n, right, which is less than this, and that's why the time complexity of this code is this. We take the bigger term, right, and the space complexity, that is also dependent on this. If this is in place sorting, then the space complexity is O1. If it's not, if we created a copy, then in that case it's O of n, right? So this depends on which sorting algorithm we are using, right? Because we don't use any, so we use this variable, but these variables are not dependent on the input. It's not growing when input size is growing, right? So like this code has O of 1 space. Well, we care about the space complexity that is coming from this internal function. Okay, I hope you like this video. Please like, comment, subscribe my videos. Thank you.